project, but today I'm here to talk about something called Monoplasma. Monoplasma is a new special purpose off-chain scaling solution for one-to-many payments. We created Monoplasma because we needed it, but it's reusable, so we wanted to spin it off as a separate little contribution to the Ethereum scaling space. I hope you guys find it useful. Here are some of the things you might want to use Monoplasma for. Revenue sharing, and that's actually something that we're going to use Monoplasma for, and I'll talk more about that a bit later. Other use cases include paying out dividends or staking rewards, doing frequent airdrops, all kinds of loyalty reward schemes, maybe pension payments even, and so on. Basically, anything where you repeatedly fan out value to a large and dynamic set of addresses and want self-service withdrawals. So this talk is only around 15 minutes, so I'll turbocharge through why we needed Monoplasma for Streamer, and then explain what it does and what it doesn't do, and finally we're going to see a live demo. So awesome, let's get started. To help understand why we needed Monoplasma, I'll briefly explain the basics of Streamer. So Streamer is a pub-sub messaging network for real-time machine data, such as data from, IoT sensors, smart cities, connected cars, crypto market data, and whatnot. So it's not a blockchain, it's a companion network for one, such as Ethereum. It basically delivers messages from data publishers to data subscribers in a robust, decentralized, scalable way. And there's all kinds of nice cryptographic stuff going on, such as, sequences of messages can be signed and made tamper-proof and so on. So that's kind of like the base layer. Now, on top of this base layer, there's a marketplace dApp, which allows these data publishers to sell access to the data streams they are producing. And the thing we needed Monoplasma for is related to the marketplace. So let's drill down to that. On the marketplace, we're working on a new feature called community products. Essentially, we want to enable large groups of data producers, such as end users owning some connected gadget like a Fitbit or a Tesla, to pool data into this collective data product on the marketplace. Now, pooling the data is not the problem. The problem is when somebody buys the product, there's this payment, there's revenue, and that revenue needs to be shared among the data producers into that collective product. Now, if there's just a handful of them, like in this picture, this is no problem to do on-chain, right? But if there's, let's say 100, your transaction size will start growing, right? And you'll start to approach the block size limit, and at some point this becomes impossible to do on-chain. Now, in our use case, there could be hundreds of thousands or even millions of data producers into this collective data product. So distributing payments to these huge crowds is just nowhere near possible to do on-chain today. So we built Monoplasma. Our requirements were these. We need to distribute these individual lump sum payments to large groups of recipients. A little bit like doing an airdrop every time new revenue enters the system. The recipients must be able to accumulate value over time and withdraw when they want by doing an on-chain transaction. The recipients must be able to join the system without doing an on-chain transaction or placing a stake. Now, this is a little bit different from other payment channel stuff out there, and in fact, it's crucial for us, because in our case, the users are mainstream end users, and we can't have obstacles for joining, such as having to, go and buy ETH on day one. And finally, the system should be trustless and transparent. Now, we didn't really find existing solutions that would fulfill these requirements, so we rolled our own. Obviously, we were inspired by the different Plasma variants and the payment channel stuff out there, but we basically threw out everything that we didn't need in order to find the simplest possible mechanism that does what we want, and only that, while maintaining good security properties and trustlessness. Today, we don't have time to cover all the little differences and similarities between Monoplasma and other solutions in the same family, so I'm going to focus on the main difference, which is this. So, we sacrificed generality in favor of special purpose, right? This is not a generic payment system where everyone can arbitrarily transact with each other. No, this system is unidirectional. That means that there are no transfers between accounts on the side channel. In other words, tokens cannot be spent on the side channel. Now, why is this useful? Well, since tokens cannot be spent on the side channel, there is no double spending problem, which simplifies things immensely. The account balances on the side channel can only increase. They are your your cumulative lifetime earnings, right? They can only increase monotonically, and hence the name actually Monoplasma. So if the account balances can only increase, what about withdrawals then? Well, withdrawals are tracked on-chain instead of off-chain. So on the off-chain side channel, that keeps track of your lifetime credits, your positive balance. And the on-chain smart contract records your lifetime debits, your negative balance. So the withdrawable balance at any time is obviously the difference. And to withdraw, what you need to do is to prove your positive balance, the positive component, to the on-chain smart contract, as it already knows the negative component. And you do this by providing a Merkle proof, just like in many other Plasma-like solutions. So let's look at a simple example. Let's say our earnings on the side channel are 100, and we can provide a proof to the smart contract, and the smart contract has already seen us withdraw 30. So in this case, it would let us withdraw 70 from the smart contract and update its state to say withdrawn 100. So now if we provide a proof again to prove we've earned 100, the smart contract knows we've already withdrawn 100, and obviously it will give us no more tokens. So as you can see, the withdrawal proof mechanism is very simple, but quite elegant. Let's cover some other aspects of Monoplasma. So there's an operator-validator model. The operator is in control of the off-chain state. And in Monoplasma, he's actually the only party who can cheat. And the job of the validators is to make sure that he doesn't. Both the operator and validators maintain the off-chain state in a Merkle tree, and the operator periodically publishes the root hash to the on-chain smart contract to enable withdrawals from that state. So this is all familiar from many other Plasma variants as well. One difference, however, is that there's no challenge period / exit game, as there can't be double spending. Instead, there's a simpler, non-interactive freeze period that allows time for the validators to exit people's funds from the last validated honest block in case the operator is caught cheating. So this means that earned funds do become available with a few days of latency, which is fine for many use cases, including ours. Monoplasma lives in the Streamer GitHub at streamer-dev/monoplasma. And it's already been forked 5 times. Yay! Awesome. It ships with a revenue sharing demo, which showcases the functionalities of the framework. So enough talk. Let's see if all of this works. Time for the live demo. Let me just mirror my screen here. All right, with this mic I need 3 hands, but let's see how we manage. So here I have, in my terminal, I have the operator running. I'm running against Ganache. It might as well be the main net, but speeds things up a little bit for this short demo. In another tab I have my validator running, and in Brave I have the demo UI. So this is basically like a control panel. So it's a revenue sharing demo. I can inspect the state of an individual in the revenue sharing pool. I can see the state of the overall pool. Now everything is 0 still. I can see a list of the blocks published by the operator. I can do transactions to add revenue to the pool, and I can add people, addresses, Ethereum addresses to the pool. So in my MetaMask, I have configured 2 addresses here. I have Alice and Bob. And we're going to start with Bob today. I'm just going to go ahead and copy-paste Bob's address over here and add him to the pool. So now we see that there's 1 member in the revenue pool. But that's kind of a boring demo. So let's add some more people to the pool. Here I happen to have 99,999 other addresses that I'm also going to add to the revenue sharing pool to show some scale here. So let's go. All right, now we see that there's 100,000 Ethereum addresses in the revenue sharing pool, but no revenue just yet. So that's where Alice comes in. You see, Alice is rich. She has 1 million unicorn tokens on her account. So she's going to add some revenue to the pool by sending some of those tokens to the Monoplasma smart contract like this. Let's do 100,000. Now the operator should publish a block here for that state. We can see that it's still in the freeze period, which is 20 seconds in this demo. In real life, it would be in the order of a couple of days. So we can see there's now 100,000 tokens in the pool. They are still frozen. When the freeze period is over, they will become into this category available. Let's do that a couple of more times, just to show how the value accumulates there. So we have like incoming revenue into the pool for as long as we want. Let's do a couple of more. Let's say 600,000. All right. Now we should have a total of 1 million tokens in the revenue sharing pool. And in this demo, these tokens get distributed evenly among the members in the pool. So we have 100,000 members, so everyone should now have earned 10 tokens in the pool. So this gets us back to Bob. Now let's switch to Bob in Monoplasma. Here we can see that Bob currently has 0 unicorn tokens in his on-chain wallet over here. But let's inspect Bob's state on the side channel. We should see that Bob has 10 tokens on the side channel. They are now in the Monoplasma smart contract, and the side channel knows how many he has. And what he needs to do to withdraw them, maybe he wants to spend them, he can provide the Merkle proof to the smart contract to withdraw those tokens. The easiest way to do that is to click this withdraw button over here. Now, this does a transaction, and that includes the Merkle proof. And when I click this confirm, just watch this number over here. Boom! So earnings available goes to 0, total withdrawn goes to 10. Now, that may not seem so exciting, but actually something very, very cool just happened here. If we go back to his wallet, we can now see that Bob now has 10 tokens in his wallet. So what just happened? Let's summarize a little bit. So we added 100,000 members into the revenue pool. We did a few transactions to add tokens, 1 million tokens to the revenue pool. And then one guy out of 100,000 decided that, okay, I want to withdraw. And he withdrew his share, 10 tokens, by doing a transaction, providing the Merkle proof, and now he can spend his tokens on-chain and do whatever he wants. There's one little thing I'd still like to show you before we finish, and that's this big red button over here that says Steal All Tokens. So when I click this button, the operator will commit fraud, right? He will try to steal all the tokens for himself, and that should trigger the attention of the validators. I'm going to click this button. We can see that the operator publishes a fraudulent block with just one member in it, himself, obviously, and it's still in the freeze period. So now is the time for the validators to act and try to prevent this. So we can check back into our terminal, and this validator, this validator was configured to exit these 5 addresses if something bad happens, and so it has done. And now when the freeze period is over and the validator, the operator tries to close the fraud and withdraw the tokens, that we can see that that transaction would not succeed anymore. Awesome. So this was just a quick scratch of the surface. So tomorrow there's going to be a Monoplasma workshop at 10:30. So if you want to learn more and especially talk more about how to apply Monoplasma in your projects, then be there. Thank you and good luck. I think we're pretty much out of time for this session. So come grab me or let's meet at the Monoplasma workshop tomorrow.